Homeostasis and response. Now, when I go outside, it's a cold day. And what does my body do in response? When it's very cold, what does your body do? Someone tell me.
It shivers.
It shivers. Why does your body shiver when it's cold?
So it can warm up.
It can warm up, yeah? So your body has a way of maintaining your temperature. Also, if you get cut, what does your body do? It repairs the cut. If you're falling off balance, what does your body do? It tries to put you back into balance. So homeostasis is this process by which your body tries to keep everything in balance. One of the most important things for your body is temperature. If you look at internal body temperature, the temperature inside of you, the temperature at which your organs are, it's always going to be 36 to 37 degrees Celsius, okay? Anything higher than that, if you go 2 or 3 degrees higher than that, you die. So when you go outside and you shiver, the shivering is there to keep your inside warm, is to keep it at that temperature of 36.7 degrees Celsius, because your body wants to stay at that temperature. If the temperature gets too hot outside, you will sweat. Again, that's to get rid of heat, so your body can keep down its temperature and keep it at 36 degrees Celsius. It's very important for the body to maintain a constant temperature, because what happens when your body temperature gets too high? Can anyone tell me? Yusuf?
You die.
What's the danger that happens when your body temperature gets too high?
You can die.
You can die, exactly. But why? Why can you die? Like, why do you die if your temperature gets too high? What's happening in your body that's messing up?
Because the enzymes stop working.
Very, very good. The enzymes start to get denatured. At a high temperature, the enzymes start working and you end up dying. So homeostasis is this process, okay, by which you control what's inside your body. I want you guys to copy down the red bit. It says homeostasis means controlling internal conditions in order to maintain optimum conditions for bodily responses. All that means is your body tries to keep inside or internal conditions the same so that you can respond to something properly. So have you covered this in school, Marco?
I've covered enzyme.
Okay.
I don't know. Maybe.
But that was a really good answer you gave me. It was a very, very good answer. That you're maintaining internal conditions. Welcome to the lesson, Huzaifa. We're just doing homeostasis today. And we're going to do a bit of chemistry later as well if we have time. There's examples in our body of homeostasis. And we need to control a few things. One of those things is temperature. We need to control the temperature in our body. The second thing is iron content. Now, we're going to look at what that means in a second. The third thing is water content. And the fourth thing is blood glucose. What I want you guys to do is to copy this table down and try and fill in the blanks of how it's controlled, okay? When you do that, we'll go through the answers and we'll explain everything. So for now, just copy the table down and fill in the blanks. It's like an exam question we're doing. That makes sense, Yusuf?
Yeah.
Okay, Huzaifa, you okay?
Yeah.
Okay, so we're doing homeostasis. How do you find homeostasis, Huzaifa?
All right.
Yeah? Okay, after the lesson, sorry, go on.
Yeah, nothing.
After the lesson, if there's any other help you need extra, Huzaifa, I'm going to sit with you alone and help you out, yeah?
All right.
Okay, if you need. So, Huzaifa, how does your body control iron content? Any idea? Not sure?
Nah.
No problem.
I know the rest, I think.
Okay, cool. Write down what you can. So think of this as an exam question, Huzaifa, like a 6 marker. You have to make about 4 or 5 good points. Do you guys know what iron content is? I-O-N.
It's like the amount of like ions you have in your blood.
Good, ions. And we'll talk about what ions are in a minute for those who don't know, but yeah. Yusuf, how do you control iron content in your body? Any idea?
I'm not sure.
Not sure? Okay, you're going to learn today. Marco, you already gave me a very good answer, so I'm giving you a little break from answering it because your answer was excellent earlier. All doing well. So temperature, someone tell me, how do we control it?
You shiver.
You shiver, yeah, you shiver sometimes, and you sweat as well. You might control a high temperature or low temperature. So your temperature increases by shivering, lost by sweating. Iron content, I'm going to show you the answer, and I'm going to explain to you in a bit what it means. You control by eating, so you increase it by eating. When you eat, there's something called ions that go in your body, like calcium ions. Calcium from milk goes into your body, goes into your bones. Nitrate ions. Nitrate comes from certain foods, goes into your body. Ions are just atoms which have a charge. Yeah. So in chemistry, you guys learned with me, the ions are atoms which have a charge. Now these ions exist in foods. They go into your body. I just had a sandwich, for example. I'm looking at the ingredients now on this sandwich. Yeah. That you can see in the camera. It's got plenty of ions in it. Okay, it's got calcium ions in it, it's got sodium ions in it because it's got salt, sodium chloride, it's got chlorine ions in it. If too many ions build up in my body, I'm gonna have a problem. So when I sweat, my sweat, if I taste it, it's salty because the salt ions come out of my sweat. When I urinate, I've never tasted my urine, never will, God willing, but it's gonna be salty. And you increase your iron content by eating. Water content, how do I control my water content? Anyone?
Through sweating and urine.
Through sweating and urine, yes, you get rid of water. And through drinking, you increase your water. Good. So there's two ways in which you control your water content. Blood glucose. So what they say is that if you have more than 2 teaspoons of glucose in your blood, it's toxic. You'll die. I put 3 teaspoons in my tea. Yeah, my tea has 3 teaspoons. I'm Asian. I drink a lot. I put a lot of sugar in my tea, as you say for now. 1 second. So now those 3 teaspoons in my tea, if it went from my stomach into my blood, all of it at one time, I'll probably end up in a lot of problems. So your blood glucose or your blood sugar has to be controlled. You can't have too much in your blood. How do we control blood glucose? What do we do?
You store it as fat.
That's one thing, but it's to do with diabetes as well. There's something in your blood called insulin. Your pancreas is an organ in your body, yeah? It makes something called insulin. When the insulin goes in your blood, it can take the sugar out of it and store it and make it into fat. So increased and decreased by hormones like insulin. So insulin is a hormone, it's a chemical that changes the amount of sugar in your blood. If there's too much sugar in your blood, the body releases insulin and it goes down because the sugar's turned into something called glycogen, and then that's made into fat. So fat is the last stage. Good idea, Josefa. Just needed a bit more there. Does that make sense, guys?
Yeah.
Yeah, so we have to understand homeostasis. Homeostasis controls mainly 1, 2, 3, 4 things. And we have to understand how they're controlled. Insulin is very important, for example. Diabetics, they have a problem in making insulin sometimes, and therefore they need to take an insulin injection, and that controls the amount of sugar in their blood. That's why diabetics carry around these injections with them and inject themselves, because the pancreas is not making insulin properly. So these conditions are controlled by our control systems. Okay? We have to understand the following, yeah? I want you guys to copy down this diagram at the bottom of the page. So if somebody gave you an exam question asking you to describe homeostasis in the body, you'd mention all of these things, then you'd mention these 3 things down here as well. We're going to talk about that in more detail in a minute. If it gets too hot, there's temperature sensors on my body made up of cells. And these cells are called receptors. They receive a signal. Yeah, they're like an aerial. So if my cells that detect temperature receive a signal of heat on my skin, they detect that heat. And then they send a signal to my brain, okay, or my spine. And my brain does a response. If it's too hot and the signal goes to my brain from the cells in my skin, my brain then switches on the circuits so that I can sweat, so I can get rid of the heat from my body. So what we do in homeostasis, we detect a stimulus. We detect something that's changing. We then make a response. We coordinate a response. Our brain and our nervous system decides what to do. And then we respond to it. So effectors, like your sweat glands, effectors are what the response comes through, or muscles, or glands. Effectors like my sweat glands will open up and sweat will come out. If it's too cold and I detect coolness, then my muscles will start shivering and I'll warm up. So the effectors are what brings about the response. The coordination is in the middle. It's what the brain does to make a response. But for the brain to do that, it needs to detect it. And that's what your receptors do. Does that make sense, Yusuf?
Yeah.
Okay. All of these points are very, very important in understanding homeostasis. So what we've looked at so far is homeostasis, homeo and stasis, maintaining similar conditions in the body. Comes from Latin. There's 4 things we need to maintain in the body mainly. And how do we maintain them? We detect if they're too high or too low. So there's detectors in your body that detect if the temperature is too high or too low, if the iron content is too high or too low, the water content is too high or too low, or the blood glucose is too high or too low. Many of them you don't even realize are happening. You don't realize your body detecting blood glucose and then it's releasing insulin. You don't realize your body telling you're detecting water. All you realize is, okay, I need to go to the toilet. That's when you realize it. You don't realize your body changing iron content or saying, look, there's too many ions in me, I need to get rid of them through urine. But you see the effect of it when you go to the toilet or when you sweat. The one we realize the most is temperature because we can sense it. Okay, so yeah, some of you are still copying. I'll leave it on for a minute. Okay. Does anyone need time to copy?
No.
No, okay. So the nervous system. We're going to look at the nervous system as an example of where homeostasis takes place. So the nervous system enables us to react to our surroundings. It contains the brain, the spinal cord, and neurons or nerve cells and receptors. So we have receptors in different places. In our eyes, we have receptors that detect light. If it gets too bright, what happens to your eye? The pupil gets smaller, which means less light can come in. If it gets too dark, what happens? The pupil, if you look at my finger on the screen, you can see it gets bigger. So more light can come in when it's dark. So you have these light receptors in your eyes. So in fact, what they say, when I used to, in the military, for example, they say, if you're on a dark road at night, you want to stay there for a long time in the dark and your eyes will get used to the darkness. So they'll go very, very large and they can take in the most light. And if you're in the darkness for long enough, it becomes almost as good as daylight. Your eyes can see almost as good as daylight if you're in pitch black. But what happens as soon as a light hits your eyes, it will mess it up. If you're in complete darkness, your eyes become very sensitive. But as soon as light hits them, bang, it goes down. So they say if you're in the army and you're traveling at night on a road, if there's any cars coming, look away from them. Because when you look away, you'll protect your eyes, you'll protect your night vision. So light receptors in the eyes, sound receptors in the ears, taste receptors on the tongue, smell receptors on the nose, and touch, pressure, and temperature receptors on the skin. There's many types of receptors. This PowerPoint I'll email to all of you after anyway, so anything you miss, you can get later. Can I move on?
Yeah.
Okay. Changes of position receptors in the ear, balance. So when boxers punch each other in the head, when the knockout happens, what happens is you're messing around with the receptors in the ear as well. Because of that, you lose balance, and it helps you to get knocked out. Nervous reactions. So, Huzaifa, can you tell me how a nervous reaction works?
You have sensory neuron. So, like, let's say something happens, you get stung by a bee.
Yeah.
The sensory neuron will send that to the brain or spine,
Yeah.
where it will organize a response, which will be done by the effector, which is a muscle.
Good. So so what happens, there might be a stimulus, something in our environment that changes, yeah? When that stimulus happens, our brain and spinal cord work together. This is what we need to do, yeah? We need to write it down like this. First is a stimulus, then a receptor detects it. The receptor sends a signal to a coordinator. The coordinator is your brain or your spinal cord. That's what to do with the signal. That then sends a signal to an effector, which is a muscle or a gland that does a response, moves or does whatever, okay? A man and a camel, for example. Man sees the camel and runs away. He detects it with his receptor in his eyes. Then his body coordinates a response. His muscles start working and he runs away. That's his response. So all I need you guys to do is copy down nervous reactions, the title, and this series here with arrows, just to summarize where it is. For some of you, this is just pure revision. For some of you, it's new. Okay. So I'm not going to punish you with this. I'm going to look at something else. Conscious actions. What's the difference, Josepha, between a conscious and an unconscious action?
An unconscious one goes to your spine, but a conscious one goes to your brain.
Okay, and a conscious one, you can think about what you're going to do. An unconscious one, you respond without thinking. So, for example, if you touch a hot gas cooker, you'll react without thinking. Yeah. So, a conscious action is where the brain makes a considered response. So, here's what happens: you get bitten by a dog, or you get licked by a dog.
Okay.
Yeah. The impulse is carried by sensory neurons to the spinal cord. Here, the sensory neuron carries the electrical signal to the brain. The brain decides to move away the hand. The electrical impulse is sent by the motor neuron to the effectors, and then you move your hand away in response. Does that make sense to everyone?
Yeah.
Yeah.
Okay. Does it? So what we're going to do, I want you just to summarize that in a paragraph, guys. Yusuf, you there?
Yeah.
I'm going to ask you a random question while you copy this.
Yeah.
Why is an element in group 2 of the periodic table? Why do we give a group number to elements? What does it tell us?
Wait, can you repeat, please?
Yeah. So if you have an element in group 2, like calcium, for example, why is it in group 2?
Is it in order of the reactivity?
No. What about the number of electrons in the outer shell? Do you remember that?
A bit.
Okay, so your chemistry needs work. No problem. Why is an element in period 3, for example? Why do you put an element in a particular period?
I'm not sure then.
Okay, it's the number of shells. So
Oh,
yeah, your chemistry definitely needs some work here. We'll talk about that later. I just want to see how much you know, so then I can tell you if you need chemistry. But yeah, no problem. Just get this done first, and then we'll move on. Huzaifa, answer ready?
Yeah.
Okay, read it out to us without looking.
All right. So the receptor in the skin detects a stimulus.
Mhm.
A sensory neuron sends a signal to the CNS, either the brain or the spine.
Okay.
Where a reading neuron sends a message from the what's called sensory neuron to the motor neuron.
Oh, good.
The motor neuron then sends a signal to a muscle or gland to organize a response.
Very good, very good, very good. So you've hit 6 marks there, yeah. So I'm going to test you a bit differently to others today for sometimes, because I want to get you ready for an exam. Okay. So when I give notes to the others, maybe I'll ask you a question in return. Also, after this lesson, we're going to go through some extra stuff. Okay, guys, done? Marco and Yusuf?
not yet.
Okay. Thanks.
I'm on number 3.
Number 3. Does it make sense to you?
Yeah.
Okay. So while they're copying for Zayfa, let's have a little chat about work. So let's make a little plan of what we want to do with learning, yeah?
All right.
Okay. So first of all, let's try and remember some difficult topics that you find difficult in.
In science.
Yeah, in science, basically. We'll talk about maths as well, but let's think about science today. I'm going to give you some maths homework later anyway. What do you want to cover in science? Like that you think? Take your time to think about it.
See when you have to balance equations using like a fraction, like
Okay.
so you have to work out the I think it's the AR and the moles.
Yeah.
And then you use that you do like a fraction or something, and then you use that to balance it.
AR. Is it to balance the equation or to make a formula?
To balance the equation, I think.
Do you know, because that's not ringing the bell, do you know what topic, have you got any examples of that?
I think so.
Yeah, show me on your camera what you got.
All right, wait, let me find it.
Or have you got my number, right?
Yeah, but that does.
Okay, no problem. You can text me on WhatsApp or you can show me on camera. It's up to you. Have a look for it. Go on. Let's do a little one while we wait.
I'll be back. See you.
Okay, like Arnie. Is it making sense, Marco, what you're writing?
Yeah.
Good. So I'll be sending you guys homework every Sunday evening, and you can work on it and give it to me the week coming up.
I'm finished.
Finished? Excellent. How far are you, Yusuf?
I'm finished as well.
Okay, excellent. Let's move on, guys. Okay. So I want you guys to see this thing at the bottom. Look, so basically, when we have an action, we have this situation, stimulus, you detect it, the receptor takes it, goes to a coordinator, goes to an effector, goes to a response. Now, second bit, more detailed. Stimulus goes to receptor. From the receptor, if you can see my arrow, it goes to your sensory neuron. From the sensory neuron, which is, it's like a wire that sends a signal. Yeah, like an electrical wire in your body. The sensory neuron sends a signal to a coordinator, which is your brain or your spine. Your coordinator then sends a signal through a motor neuron, which is like another wire. That wire connects the brain to the effectors, those things that make the response. Then it goes to an effector, then it goes to response. So now we need to get this more detailed version down, now that you understand it. Okay, so now, next bit, guys. So reflex actions. Now, Josefa will tell you, a reflex action is one where you automatically respond to something without thinking. Okay? So sometimes conscious actions are too slow to prevent harm. If someone does something to me and I can think about the response, that response takes time. It takes me time to think. If I get shocked by an electrical circuit like this baby's doing in a second, yeah, it's putting a fork into an electrical socket. When that shock happens, the baby doesn't know what to think. It's young. It doesn't have time to think. So it's amazing how naturally we have the ability to avoid problems. When you get shocked, automatically your body will pull your hand away without you even thinking. This is called a reflex action. It's an action you do without thinking. And your brain doesn't get involved here. What happens is basically, in situations like this, the body bypasses the brain. It says, you know what, brain, forget you. You're going to take too long to think about it. I need a quicker answer. I need a quicker response, or I'm going to die. Here's how it works. So you might touch something hot. The receptor detects it. Then it goes to your sensory neuron. Then it goes directly to what we call a relay neuron in your spinal cord. It doesn't go to your brain. Normally after this, it goes to your brain. Your brain thinks about what to do and sends a signal. In a reflex action, the signal goes straight to your spine. It doesn't even travel to the brain. And your spine automatically reroutes it and gives you a response back again so you can move your hand away. It happens automatically from your spine, like a boomerang, in and out. So the relay neuron in the spinal cord, this sends a signal now straight to the motor neuron. The relay neuron is this thing, you know, like in a relay race, someone that passes one thing to another person, it passes the message. It passes the message from the sensory neuron to the motor neuron. It's in between these two guys. It passes the message that, you know what, you need to move your hand away. The relay neuron sends that signal to the hand, to the muscle, and then the effector or the muscle moves it. So you're bypassing the conscious part of your brain, which means your response can be much quicker. Does that make sense, guys?
Yeah.
Okay, so Marco and Yusuf, I want you to summarize that. Reflex action, you don't have to draw this, but I want you to summarize what's going on that page, and then read the answer to me in a minute. Josefa, show me what you got.
Yeah.
Okay. When your camera's on, I'll have a look at it. Just so I know what you need to do.
So it's like, wait, where's it?
Okay.
This stuff.
Okay. Can you do me one favor?
Yeah.
Can you take a picture of it and send it to me on WhatsApp right now?
Cool.
Okay, thank you. Okay.
Yeah, I'll come back.
No problem, take your time. Okay, Josefa, I've got your thing. Josefa, I've got it, yeah? Excellent.
Yeah.
Check it. Ah, okay, it's empirical, kind of. Okay, so I'll teach you this. So I'm just going to have a quick look at it while you're... Okay, what about... Oh, Josefa, you're going to find this very easy. I'm going to teach you. I'm going to teach you this today after the lesson. You're going to find it easy, inshallah.
All right.
Okay. All right. Any other topics you can think of? We're going to do them as well. Yeah, no problem. Okay, Marco and Yusuf, how is it going?
Nearly finished.
Nearly finished. So, Josefa, if you look at your textbook with this question, is all you've got to do. You write out the general equation. So zinc oxide plus ZNO plus C. Yeah.
Right.
And then put an arrow. CO2 plus Zn. Does that part make sense so far?
Yeah.
Okay. Now, work out how many moles of each one there are. Do that next.
So I finished.
Okay, finished? Read out your answer to me, Marco.
You touch something hot, then the reaction goes to your sensory neuron. Then it goes.
The signal goes through your sensory neuron,
Yeah.
yes.
And it goes to the spinal cord instead of going to the brain.
Okay.
So it does a quick reaction and goes back to the hand and reacts.
Very good. All you've got to add to that is, in the spinal cord, is sent the relay neuron, sends it to the motor neuron, then it goes to an effector and you react. So just make those points, yeah? Okay, fix your answer with that. Very good answer. Just needed a bit more technical language in the second part. Yusuf, read your answer to me. Huzaifa, did you work out the moles yet?
Yeah, I worked it out.
Okay, and you see now underneath the equation, underneath everything, write down how many moles there are. So in zinc, zinc oxide, you got 0.1 moles, right?
Yeah.
The carbon dioxide, you got 0.05 moles, right?
Yeah.
For carbon, you got 0.05 moles as well, right?
Yeah.
And for zinc, you got 0.1 mole, right?
Right.
Now, make a ratio of them. So the smallest one, divide it into itself, and then divide that number into everything else.
Oh, okay.
Okay, look at what happens. 0.05 is probably the smallest one. Yusuf?
Yeah.
Yeah, do you want to read your answer to me?
Yeah. So I said okay. I said the spinal cord sends the signals to the muscle through the motor neuron.
Yeah.
And then the motor neuron sends it to the effector.
Okay, but is that your full answer?
Yeah.
So a full answer needs a fuller, it needs the whole situation. So you got to write, your receptor will detect the stimulus. The signal will then be sent through the sensory neuron to your spinal cord. In your spinal cord, a relay neuron will send a signal to your motor neuron. Your motor neuron will then send the signal to the effector, and then you'll move or you'll react. Does that make sense?
Yeah.
And this will happen because your reaction needs to be fast and you haven't got time to think about it. So Yusuf, a target for you now is a homework tonight, write down HW, is explain the reflex action fully. And I want you to send me a picture of your answer, hopefully this week.
Yeah.
Okay, so we need a full explanation. Huzaifa, are you seeing what's happening?
Yeah, so it balances out, innit?
Exactly. Then you just put those numbers in front.
Oh.
Simple, isn't it?
Yeah.
I told you you'd find it easy. Okay. So now, we're going to do more afterwards anyway, Huzaifa. As you think of more things, we'll do them. So types of nerve cell. Now, Marco, Yusuf, and Huzaifa, you're generally okay with this so far, yeah?
Yeah.
Okay. So we're going to look at types of nerve cell. First of all, what's a nerve cell, Huzaifa?
It's a specialized cell.
It's a specialized cell. What does it do?
It transfers electronic impulses.
It transfers signals. So basically, good. You see these neurons, they send signals around your body. Yeah, this sensory neuron, the relay neuron, the motor neuron, they all send signals around your body. They're made up of something called nerve cells. They're very important cells. Okay. When you have nerve damage, sometimes people get nerve damage in their hand. It means their neurons won't work properly and they can't sense heat. My dad, for example, he had a stroke in 2015. May God cure him and make him better. He had a stroke in 2015, and in the stroke, he damaged some parts of his brain. So his neurons now, when they send a signal for heat to his brain doesn't realize that there's heat, and he can touch something hot and not realize it's going to burn his hand. If your neurons get damaged or your brain gets damaged, where it processes the information, you won't sense things. So these sensory neurons are made up of what we call nerve cell. And there's different types of nerve cells. But first, we need to label a nerve cell. If I gave you this to label, Huzaifa, could you label it?
Probably.
Okay, so I want you to draw this out from memory and label it. And for the rest of you, Marco and Yusuf, I want you guys to draw this and copy it, yeah? So Huzaifa, without even looking at it now, try and draw it out and label it. student exam, right? And you, Marco and Yusuf, you're going to try, draw it out, and then just label it together. Is that clear, Marco?
Yeah.
Okay. Yusuf, am I talking too fast, or do you understand it?
Yeah, I understand.
Perfect. Okay, once that diagram is drawn, let's label it. So a nerve cell, it's quite complicated compared to normal cells. It has this. What does the nucleus usually contain, guys?
Chromosomes.
Chromosomes or DNA. Every nucleus generally contains DNA, and that gives the cells instructions of what to do. So, for example, like now in coronavirus season, what the coronavirus does, it will get into your cell, and it will get its DNA in your cell, and then your cell will start making more coronavirus copies, and then the cell will explode and it will come out, all of these copies. We can talk about that another time. It's quite interesting how it works. So the nucleus. Then it has a cell body. The body is what the nucleus is inside. Then this nerve cell or this neuron it makes up a neuron that connects to your muscles or your effectors. So when the signal goes to your hand for you to move your hand away from a fire, it goes through this neuron, yeah, the motor neuron. This is what a neuron is. It's made up of a nerve cell and something that looks like a wire. That sends a signal to your muscles, and then your muscles start moving, get pulled back. So nucleus, cell body, muscle strands are effectors. That's what you've got at the end. Now, nerve cells, also known as neurons, are elongated. They're quite long. Yeah, you see this nerve cell here, with my arrow is, it stretches out and becomes a pipe. And that pipe goes all the way to your muscles. If your nerve gets damaged, then your muscles can't move. In Thai boxing or Muay Thai, what they do, they kick you very hard on your muscle, yeah? And you get a dead leg. Your leg can't move, your arm can't move. Because what happens, the signal can't get to the muscle anymore. It's had so much damage to it, the signal doesn't get there and you can't move. If you've ever been kicked hard in the leg and you've collapsed and you can't get up, you know how that feels. It's basically what happens. Okay, so motor neuron, sensory neuron, and relay neuron. There's 3 different types of neurons, okay? In a motor neuron, the cell is at the start. In a sensory neuron, the cell is usually at the end, the body of the cell. In a relay neuron, the body of the cell is usually in the middle. So I need you guys to copy that down in case you didn't know. So when you done this diagram, Huzaifa, were you able to label every part?
No.
No? Which ones did you get a bit, were you off on a bit?
No, I didn't clock the muscle strands.
Oh, okay. Yeah, in an exam, they'll show you this as well. So it's good, you can see now.
Definitely.
Okay, Yusuf, want a breather?
Yeah.
Okay, let's have a 10. 5 or 10, guys. You guys vote.
10.
Okay, let's do 10, and then let's come back to it, yeah? Stay on the system. Don't log off or anything. Otherwise, the classroom will go. Stay logged on. In 10 minutes, we'll be back. So at 5:10. Okay, guys, it's 10 past. Let's get back to business. Can I confirm who's back, please?
Yeah, I'm back.
Yeah.
Excellent, everyone's back. Okay, so far, just to recap, what have we been looking at? We've been looking at homeostasis and stasis in the body. It's always good to have a quick recap because the mind forgets. So we understood homeostasis is the way in which the body maintains conditions and safety. It has responses to do that. To do homeostasis, you have 5 areas which you need to control: temperature, iron content. Ions are things like calcium, sodium, chlorine. These exist in your body. These elements exist in your body in the form of ions, charged atoms. Now, if you don't know what ions are, we did study in chemistry a few weeks ago. I'll recap it for you at some point. But for now, just understand it's something in your body that needs to be maintained at a constant level. Too much or too little, you'll end up in problems. Water content and blood glucose or sugar. So we said these are the 4 things that your body needs to maintain. How does it maintain it? Well, first, you have to detect. You have to be able to sense these things. How much temperature is there? How much iron content is there? How much water content is there? And then your body has to respond and make it either lower or higher. So sensing and responding. This led us to the next bit, which was the nervous system, which includes a part that senses and a part that responds, and a part in between that sends the signal between the sense and the response. Okay, so we looked at that. We said it breaks down into this. You get a stimulus, your receptor senses it. It then goes to a coordinator. then it goes to an effector, and then you have a response. You guys now know what all of these parts are, hopefully. Because you know that, we went into more detail, and we looked at two types of response. Conscious actions, which you think about, and unconscious or reflex actions, which you don't think about. Amongst the reflex actions, we have things like sweating. You don't think about sweating, you just do it. Your body controls some things without you needing to think about it. One of the most obvious examples we said was when you touch an electrical socket and you move your hands away. This is a reflex action. The signal in this case only goes to your spinal cord and then goes to an effector to save time. We looked at nerve cells. You drew a diagram of it. You labeled the different parts. And we understood a little bit that there's 3 different types of nerve cell involved in neurons. Nerve cells involved in neurons have 3 different presentations. One like the one on the left, one in the middle here, and one on the right. Are we all okay so far with that, guys?
Yeah.
Yeah.
Okay, so we've comprehensively covered that part. Synapses. Who can tell me, apart from Huzaifa, what a synapse is? Marco?
I'm not sure.
You're not sure? Yusuf, any idea?
I'm not sure as well.
Okay, it means we're going to learn something. Huzaifa, tell me what a synapse is.
It's the gap between 2 neurons.
Very good. And Huzaifa, can you add to that? How does a synapse send a signal across? What happens?
The electronic impulse gets to like the bottom of the muscle strands,
Okay.
and the chemicals, they like all diffuse across the gap.
This is good. The electrical impulse goes to the edge of the synapse, and then it diffuses chemicals across the gap. That's correct, yeah? We're going to look at a more comprehensive way of saying that in a second, but it's good, you're right. So basically, it's like 2 roads. In real life, we find when 2 roads are near each other, they connect in some way. So a car can go from one road onto another road. Synapses are the gaps between neurons. So a neuron is like a road down which a signal goes. If you follow my mouse on the screen, look, the signal goes down this neuron. But a neuron doesn't go on forever. They have a limited size, just like humans. So what happens when the signal goes down a neuron to the end, it might need to jump onto another neuron to get to the effector. Your brain might be here. It might be sending a signal. The signal's going down, and then there's a gap. This nerve cell is connected to your muscle. So the signal has to get across the gap. You don't have a direct path from the brain to the muscle. Often you have many nerve cells next to each other with gaps between them. So the signal has to jump across the gap. It's like you passing a ball to your friend. The signal has to jump across. This gap here is known as a synapse. So what I want you guys to do is copy this down, this fill in the blanks task, and leave a blank if you don't know the answer, which you might not do, and fill it in where you do know the answer. And then we're going to go through it. Okay? Is that okay, guys?
Yeah.
You copied it? Rest of you done?
Yeah.
Yeah,
Okay.
yeah.
So let me tell you guys a little bit. I'm going to draw a little diagram here to show you something. Okay. So let me open up the diagram. Okay. So basically what happens, and some of you might know this already, it's just a recap. You have this nerve cell. Yeah, I'm going to draw a rough picture. It sends a signal down a neuron. Okay. And then you have another nerve cell over here. It can happen in different ways, but I'm just going to draw a rough diagram and you've got your neuron. What happens, electricity can travel along the neuron very easily. Yeah, your body sends signals using electricity. This is why electric shock kills you, because it confuses the signals. The electricity goes to the end of the neuron. It has nowhere to go. It can't jump across this gap. So what happens at the end of this neuron, when electricity goes there, the neuron releases chemicals instead. These chemicals. It releases a lot of chemical over here. And if you have a lot of something, it goes to somewhere where there's less of it, so it diffuses. And the chemical travels to this one, this neuron over here. Once the chemical travels here, it sticks to this neuron. And then it's what it does, it switches it on. And this neuron then sends a signal down here. So what happens, let's say you feel something, you sense heat. Yeah? The signal goes down your neuron. Before it gets to your brain, it has to jump across these gaps. So what happens at the end of every neuron, chemicals are released. These chemicals travel across the gap, hit the other neuron, create another signal, and then that ends up going to your brain. So neurons don't just work using electricity, they also work using chemicals. The chemicals are sent between the gaps. So there's two things involved in the nervous system, electricity and chemicals. Now, if we go back to our PowerPoint, knowing that, it becomes easier to look at this task that you have to do. So, if I look at this, Marco, what could I say first? Neurons never do what to each other, Marco? Touch each other. There's a small gap between them called a what, Yusuf?
There's a small gap between them called a synapse.
Perfect. The gap is known as a synapse. A signal is sent from one synapse to the next by a chemical transmitter. Between them, there's a chemical sending the signal across, as we just saw, yeah? These transmitters are then, after the signal sent, the transmitter is destroyed. Because if it doesn't get destroyed, it will carry on sending the signal, and you'll carry on moving your hand away from the heater even after the heater's gone. Does that make sense, guys?
Yeah.
Yeah.
Okay, perfect. So if you write the blanks in, we can move on. Okay. So, guys, have you written the blanks in, Marco and Yusuf?
Yeah.
Okay.
Yeah.
Excellent. So the brain, let's look at the next part of the nervous system, homeostasis, the brain. The brain controls complex behavior. What is complex behavior? What we're doing now, we're doing very complex behavior. A monkey could not do what we're doing right now. Can't sit in front of a computer, process information, write things down, and think about it at a very high level of intelligence as humans do. So our brains are very complex, more than other mammals. So it controls our complex behavior and is made up of billions of neurons and different parts or different regions. So here's your brain. Now, what's the bottom of the brain called? Does anyone know? It's called your stem. It's like the stem of a plant. And when people get hit too hard in the head, the stem gets damaged. And when that gets damaged, they start having anger problems and all sorts of things. You know about soldiers coming back from war, they get a lot of head trauma, a lot of head injury because of explosions and stuff going on near them. They come back from war and they're depressed and they have all of these symptoms because their brain's been injured. So cerebral cortex is responsible for your thought and intelligence. Your cerebral cortex is at the front of your brain. Okay? It's responsible for your thinking and your intelligence. The medulla at the bottom, something called a medulla oblongata, but here you just need to know the word medulla, controls automatic actions like breathing and circulation. Yeah? This is why if you hit someone too hard in the head, they die. Part of the reason is you damage this and your breathing stops. Cerebellum controls movement and balance. So it's at the back of your brainstem. Okay, so I want you guys, you don't have to draw a picture of the brain, you can draw a rough picture, just to copy this to know all of the different parts, okay? We're learning about the brain now. So even for those of you who have been learning well, you're going to find things, extra things sometimes, that will help us in our exams. When a person lies, they think about it in this part of the brain, right at the front. Yeah, this is creative thought, where you can make things up from, basically. A lot of the brain, we don't know what it does. We only understand 10% of it. And we've only seen 10% of it being used, I think. The rest of it is a mystery to humans. It's with us all the time, yet we don't know 90% of what it does. It's amazing. Okay, guys, ready?
Yeah.
Okay, Marco, ready?
Not yet.
Not yet? Okay, Yusuf?
Yeah, yeah.
Okay, Marco, just tell me when you're ready, we'll move on, yeah? So while Marco writes, if you can think about other things we need to go through as well, because we'll do some extra stuff today if you need. Which one you on, Marco?
I nearly finished the second one.
Okay. So you're going to be on cerebellum next.
Yeah.
Okay. I'll give you guys another 30 seconds and then we can move on. Yusuf, are you understanding better now about homeostasis than you did before?
Yeah.
Okay. Were these the things you were confused about?
Yeah.
Okay. Okay. Studying the brain, higher paper. So this is also going to be in any higher paper you do. We'll go through it. Okay. So we're looking at the cerebral cortex, the front part of the brain. Okay. We need to understand a little bit about what it does to get a good grade in the higher paper. The cerebral cortex is the part of our brain most concerned with intelligence, memory, and consciousness. The fact that you're awake, you know it from your cerebral cortex. When you go to sleep, the cerebral cortex activity goes down and you lose consciousness. By studying the effects when different parts of the brain are damaged, scientists have been able to identify which parts of the brain control which functions. Now scientists know kind of what part of the brain controls what. They know this part is responsible for thinking and intelligence. They know this part is responsible for coordination. In India and China, what they're doing, they want to give people brain scans to figure out if they're going to do a crime before they do it because of the way the brain's working. And then they can arrest people before they do a crime. That's not fair, but that's where it's going now. We've begun to understand the brain to such a level that people think they can predict when they find a sociopath or a psychopath, and they can identify them in advance. Don't copy any of this, it's just extra. Okay, so you can see, look, here, there's different things. The front of your brain, reasoning, problem solving, emotions, personality, all of these things are from the front of your brain. Your back, cerebellum, controls balance and coordination, homeostasis. Yeah, a lot of homeostasis happens from there. The brainstem regulates basic body functions. Underneath your brain, you have a gland called a pituitary gland that controls a lot of the hormones that are made in your body. So there's a lot of stuff going on with the brain. Okay, so there's ways of studying the brain. The EEG machine helps you to study the brain. It's known as a electroencephalogram. It records the electricity or the electrical activity in your brain. What you can figure out using this is where your brain's sending the most signals, because your brain works using electricity. The machine sees where the electricity is most concentrated, and from that you can figure out which part of the brain is working. So they'll stick this on someone's head and they'll ask them to draw something. And when they draw it, they'll see the electricity in the brain is coming from the front, which means the front part's activated. They'll stick this on someone's head and ask them to balance. And then they'll find that most of the electricity in the brain is being generated at the back, and they'll realize the back is responsible for your balance. So it's really, really interesting how this works. There's another type of imaging called magnetic resonance imaging, MRI scanning. It uses colors to represent where your brain's most active. So you can see here, where it's red, it shows your brain's most active. Yeah, where it's greenish, it shows your brain being less active. Different parts of the brain light up with activity depending on what you're doing. Does that make sense, guys?
Yeah.
Yeah?
Yeah.
Okay, so that's just extra information. Now, we're going to look at the eye, yeah? So in biology, you need to be able to label the eye, okay? This is going to be a very involved task now. So what I want to get you guys to do, have you learned this in school yet, Josefa, by the way?
Little.
Little?
I think.
Okay, we're going to cover it in detail today. So what I need you guys to do is copy this diagram of the eye down first. Okay, and then try and label what you can. It's going to be a little bit of a long activity, 5-10 minutes maybe. We need to be able to label the different parts of the eye. We're going to do chemistry. We're going to do chemistry next week after we finish this.
About
The labeling.
labeling.
Okay, I'm going to put it up now, yeah? So this first bit is the iris. The iris, so people who've lost their vision, some of them, when they're sleeping, they have a dream, for example, and then they'll wake up. And when they wake up, they don't realize they've woken up and they're still in the dream. The dream comes into real life because the eye can't see what's going on around you. Does that make sense?
Yeah.
It's crazy. So people don't realize the difference between waking up and sleeping when they go blind at the start. God protect us. Also, this cornea at the front, it can get very thick. As you get older and it gets thicker, the light doesn't come in properly into your eyes and your vision goes. So they do laser surgery where they shave or they cut bits of the cornea off to make it thinner again. So that's what laser surgery does. It does the front part here. It actually makes your cornea thinner through using lasers to cut bits of it off. Your optic nerve at the back, this sends signals to your brain. If this gets damaged, your vision goes. Your eye is directly connected to your brain. It's amazing. It's probably one of the most complex organs ever imaginable. Nothing beats it. Well, a lot of things don't beat it. So once you guys have written it all down, we'll move on. We've only got 25 minutes left for this lesson. There was one guy who was talking about his injuries in war, and something exploded near him, and it sent small pieces of aluminium and metal into his eye. Yeah, and he lost his vision. And what the doctors had to do, they had to operate on his eye and take out all of those bits. And he could have lost his vision, but after a few weeks it returned, or after a few months. Done, Huzaifa?
Yeah.
Okay, done, Marco?
Yeah.
Done, Yusuf?
Yeah, I'm done.
Okay. So I was talking about extra things because I wanted to make sure you guys were copying and not getting bored. So seeing things. So the eye is a sense organ containing receptors sensitive to light, intensity, and color. How do they work? So light goes in your eye, and light travels in straight lines. Okay. What your eye does, it will focus this light. It will take this light and bend it. And it will bend it and bring it to a focus over here. So can you see what's going on there?
Yeah.
It's just how a magnifying glass works. A magnifying glass works by taking light and focusing it onto one point. And when that happens, you can make an image out of it. So rays of light are refracted first by the cornea and then by the lens. The cornea here bends the light. And then the lens bends it some more. And when you bend it and get it to one point like this over here, where you focus it, you can begin to see clearly, because then your eye takes that and makes it into an electrical signal. So I want you guys to write the title Seeing Things, and then just write this sentence. You don't have to copy anything. Just write the sentence underneath. If you bend light, it can become very, very powerful. Okay,
Yes.
I'm going to show you guys a video, yeah, an interesting one. After you copy this sentence, just to make the lesson a little less boring, I'll show you a very interesting video. So in this video that you see in a minute, they're going to get mirrors and use it to focus light, just like this cornea here is focusing light. And when you focus light, it becomes very, very powerful. Let me go. Have you copied it, Marco?
A million. I'm just at a loss.
Okay, cool. Cool. So just remember the lens, the cornea and the lens focus the light. The cornea bends it a bit, the lens bends it a bit more, and it focuses it onto something called a retina. And from the retina, you can make an image.
I finished.
Finished?
Yeah.
Okay. So I'm going to put the volume up so you can hear it.
How tight does this focus? Can we see it? Just look, yes. By spraying some water.
So what they're doing here, they're using these mirrors, as you can see at the top. The mirrors will focus sunlight. And now he's going to spray it with water, and the water will show you where the sunlight is being focused. Can you see the triangle it's making, guys? You see that?
Yeah.
Yeah. So it's doing the same thing the eye does. The eye takes light and focuses it onto a small point, just like this. I'm going to rewind it a bit.
By spraying some water.
So if my hand's here, it's okay, but if it went there, what would happen?
Not as a focus.
So I want to ask you guys a question. How hot do you think it gets here? There's an amount of sunlight that would fall on two people here. This mirror is taking the amount of sunlight that falls on two people and it's focusing it here. Do you think it's hot enough here to boil a cup of water?
Yeah.
Do you think it's hot? Sorry? Yeah. Do you think it's hot enough to melt iron?
Maybe.
No.
Maybe? No? Okay.
Yeah.
Some people say yeah. Do you think it's hot enough to be 20 times hotter than boiling water?
I don't think so.
Don't think so? Okay, watch this.
Yes. Here it's okay, but
And even a mirror this big, would it be powerful enough to kind of set light to something?
yes.
Can I try it?
Go ahead.
That's a piece of wood.
Okay. Show me the focus. I'm okay. Oh,
Do you see that?
Oh.
It's setting a piece of wood on fire.
my life. Can we do that again? That's astonishing. I've never seen anything set light to wood that quickly. How hot is it in there? What temperature does it get to?
At that focal point, we can reach a temperature higher than 3,500 degrees C.
3,500 degrees Celsius. 35 times hotter than boiling water. You boil water and you burn yourself. This is 35 times hotter than that. There's nothing on this earth that this can't melt. I put an American Abrams tank in that thing, it will melt that thing. I put a diamond in there, which is the hardest thing known on earth. It will melt. I put a block of wood in there, or metal, it will melt. Watch.
And there is currently no known materials that could resist this.
There's nothing in this world, he said, that this won't melt.
There is nothing on Earth that can withstand the temperature right in the middle there.
And that's just the amount of sunlight from two people. If you're on a beach with a friend and sunlight fell on you, the amount falling on your body and their body, if you took that and focused it, like they're doing there, there's nothing on this earth that can withstand that.
Nothing.
And I'm pointing at it.
Exactly.
Just 2 square meters of sunshine can melt steel pretty easily. I would love to try and weld some stuff with sunshine. It'd be really nice. If you had 3 people sunbathing, they would be collecting that amount of sunshine. And look what it does.
2 people.
Despite having traveled 93 million miles, the energy of the sun can even melt rock. Look at that. See, to me, that's far more amazing than melting steel. Like, I see steel melt every other day, but I've never seen anything like that.
You guys see that?
Yeah.
Your eye does the same thing, similar thing. It takes light rays from outside and brings them together, but it doesn't use them to heat your eye up. No, it uses them to make images. You focus at different distances. You might see things from far away, or you might see things from close up. Okay. Now, if the light comes into your eye focuses it, brings it together. We know that. If you're looking at something distant, far away, the ciliary muscles relax. They become relaxed, and the suspensory ligaments, not even muscles, they pull tight, making the lens thin. The light doesn't refract as much. So what happens when your lens gets thick? The thicker your lens is, the more it bends light. The thinner your lens is, the less it bends light. When you stretch something, you make it thinner. So what happens when you're looking at something far away, you don't need to bend the light that much. Your eyes don't need to bend it that much. So your lens can get thinner, so you don't bend it as much. To make it thinner, the ligaments, the suspensory ligaments, pull it. When you pull on something, you make it thinner sometimes. You tighten it up. If I pull in a plastic bag harder and harder and harder, I make it thinner and thinner and thinner. Your suspensory muscles pull on something like a plastic bag, which is your lens, and they make it thinner. And your ciliary muscles allow that to happen. They relax so that the light doesn't bend as much. You don't need the light to bend. And here, for close objects, what happens? You need the light to bend more. Your eyes need to bend the light. So the opposite happens. Your ligaments relax and your muscles pull. And what happens then? Your lens gets thicker and it bends more. It's like glasses. Sometimes you see old people having thick glasses. Why? Because their eyes don't work properly. They need to bend light more. And some people have thin glasses. You don't need to bend light as much. So what I want you guys to do is write the title down and copy these things, yeah? They're important. Does that make sense, Marco?
Yeah.
Excellent. Yusuf, make sense?
Yeah, it does.
Good. Huzaif, have you seen this before? Good. So some. Let me know when you guys are done. You have 10 minutes left approximately.
I'm finished.
Finished? Okay, good. Yusuf?
Yeah, I'm finished.
Okay. All right. Now, you don't have to copy all of this down. I'm going to just show you what's coming up in the next few slides. So we're going to look at using lenses to correct vision, using lasers in surgery, how lasers work, very easy. Controlling body temperature, a little bit more about homeostasis. We're going to talk about body temperature and how it's controlled in detail, a little bit of detail, not too much. We're going to look at how sweating works, okay, what happens during sweating. We're going to look at hormones. We're going to look at the endocrine system and labeling it. We're going to look at the pituitary gland in more detail. So homeostasis still has a bit to go, yeah? There's some stuff to cover still, which is why next week we'll do an hour of homeostasis and an hour of chemistry probably to get it finished. It'll be a very good revision for you guys. So before next week's comes in, so what you've got to understand here, you don't have to copy this down here. You just have to copy two things down here. Short-sightedness is known as myopia, and long-sightedness is known as hyperopia. Exam questions, we can go through that. So let's see how long we've got left. 3 minutes. Okay, what we'll do you guys want to call it a day? Or do you want to use the next 3 minutes to start another part of this?
Call it a day.
Call it a day? How about you, Marco? Call it a day?
That's what it is.
Okay. So Yusuf, did you enjoy that?
Yeah.